Welcome to The Explainer. Today, we're diving into a pretty wild idea. What if the universe isn't this vast, empty void we imagine? What if it's the exact opposite? I mean, what if it's completely full, a single, dense fluid that makes up the very fabric of reality itself?
So to get our heads around this, we have to start at what you could call a cosmic crime scene. It's probably the single biggest unsolved mystery in all of physics, and it goes by the name the vacuum catastrophe. And believe me, it's a paradox so deep, so profound, that it literally shakes the foundations of everything we think we know about the universe. And right at the heart of this mystery is a single number, 120. You see, our two best theories of the universe, our absolute pillars of modern physics, they disagree on how much energy is in empty space. And not just by a little bit, they're off by 120 orders of magnitude. That's a 1 with 120 zeros after it. It's so wrong, it's been called the greatest predictive failure in the entire history of science. Just mind-boggling.
All right, so let's break down this paradox. On one hand, you've got quantum field theory. It predicts that the vacuum of space, empty space, should be just fizzing with a colossal amount of energy. I mean, if that energy was actually there, its gravity would be so powerful, the universe would have just, poof, collapsed on itself the second it was born. But then, on the other hand, we've got Einstein's general relativity. And when we look out at the actual universe, that energy is, well, it's pretty much zero. So one theory says it's almost infinite, the other says it's basically nothing. They can't both be right. Or can they?
Well, this is where a pretty radical theory called S-DMT comes in, with a totally wild solution. It asks a simple question. What if the quantum prediction wasn't wrong? What if it was right all along? And what if the reason we don't see that energy is because the vacuum isn't empty at all? What if it's actually infinitely dense?
Okay, this is where it gets really, really interesting. This theory asks us to completely reimagine what reality is. So just forget the idea of empty space for a second. Instead, I want you to picture the entire universe as one single continuous fluid.
Now, they have a name for this fluid. They call it the substrate, and it's supposed to have some pretty strange properties. It's got Planck density, which is basically the densest anything can possibly be. It's also thixotropic, and that's a fancy word, but you already know what it is. Think about ketchup. When you shake the bottle, it gets thinner and flows easier, right? That's thixotropic. So in this model, this substrate is literally the fundamental hardware of our entire universe.
So this brings up a massive question, right? If this fluid is everything, then what are we? What are you and me? What is matter? Well, the theory suggests that we're basically nothing more than a disturbance in it. Kind of like a vortex or a bubble that forms inside this cosmic fluid. So think about that. We aren't just in the universe, we are the universe, just taking on a temporary shape or pattern.
And this really gets to the heart of the difference. The standard model of physics we all learn about. It says you have fundamental particles floating around in an empty vacuum. But S-DMT just flips that completely on its head. It says the fluid is the fundamental thing, and matter, well, matter is just an emergent pattern. Kind of like foam that appears on top of the ocean. The ocean is real, the foam is just a temporary effect.
Okay, so if reality is a fluid, how does that even work? According to the S-DMT model, it's all run by two fundamental pressures, and these two pressures supposedly define everything we see, from mass all the way to gravity.
All right, check this out, because this is the core of the mechanics. First, the theory says mass doesn't come from the Higgs boson. Nope, it comes from something called striction. Just imagine you're deep in the ocean in a submarine. That crushing pressure you feel from all sides, that's basically striction. And then there's gravity. It's not some weird curvature of space-time. It's just torsion, which is really just a word for the drag or the friction you'd feel if you tried to move your hand through a big vat of honey.
Now look, any good new theory has to prove itself, right? And one of the best ways to do that is to solve a problem that has stumped everyone else. S-DMT claims it does exactly that, by taking on a stubborn mathematical paradox that's been bugging physicists for more than 100 years.
It's called the 4/3 mass paradox, and without getting too deep in the weeds, it basically means that for a long, long time, the math for an electron's mass just didn't quite add up. But this theory says if you apply its idea of striction, that inward pressure from the fluid, it perfectly cancels out the problem. The math suddenly works. The paradox just disappears. And if that's true, you don't even need the Higgs boson to explain where mass comes from anymore.
But, this whole fluid model doesn't just stop at redefining matter and gravity. Oh no, it goes after something way more fundamental.
It completely redefines time itself.
So get this. Time isn't a fourth dimension that we're all traveling through, at least not according to S-DMT. Instead, time is just a property of this cosmic fluid. It's its viscosity. You know how thick it is. Time is literally the fluid's resistance to things changing.
Here's a great way to think about it. Imagine a really thick fluid, like syrup. It creates a lot of friction, right? It slows things down. Well, that's our everyday linear time, where one thing happens after another. But now, what if that fluid suddenly had zero viscosity? It would become a superfluid. All resistance would just vanish. Cause and effect would happen instantaneously, everywhere at once. And that would create what the theory calls an eternal present.
And this, of course, leads to a pretty startling question. Is the viscosity of our universe permanent? Is it fixed? Well, according to this model, the answer is a hard no. In fact, it's not only possible for it to change, the theory predicts that it will change. So the theory goes like this. For billions of years, all the matter moving through this fluid has been creating stress, building up tension, and now the substrate is supposedly reaching a critical breaking point. You know how supercooled water can just instantly freeze solid? It's kind of like that. All that built-up stress is going to force a massive, universe-wide phase transition. And this brings us to the single most specific, most testable prediction the model makes. It puts a date on it, the year 2026. That's when the fluid of reality is predicted to undergo this phase transition, shifting from the way it is now to a zero-viscosity superfluid. And if that happens, it would fundamentally change the nature of time and causality for everyone, everywhere. So in the end, what this theory really presents is a profound what if. What if the universe isn't empty space, but this single living fluid, and we're all just temporary, fleeting patterns inside of it? It definitely leaves us with a final, kind of poetic thought from the people who came up with it to chew on. In a fluid universe, mass is memory, and gravity is history.